Hi everyone, Jeremy here, and today we are going to try to make a shorter video, and we will talk about the difference in C++ between a reference and a pointer, and how to make sure that our Rust code is safe from that. So there are two interesting things in C++, which are the pointers and references. There are a couple of differences between them. A pointer is something that will refer to a value, just like a reference, but there are two different things. The first thing is a reference cannot be just declared and not initialized. For example, if I type, if I want a reference to something that equals 45, let's say that this is supposed, oh no, I need a foo. There you go. And I want to create a reference to it. Bar, that would be foo. Oh, that would be the reference. That would be foo. Okay, so this is something I can do. The compiler does not complain, but if I want to first declare it and then initialize it, the compiler is going to complain. You see, the reference requires an initializer, whereas I can just declare a pointer. I'll probably need to do that. Let's see what happens. Yeah, I can absolutely declare a pointer and not initialize it. What does it mean? It means that as soon as I do that, I am dealing with a pointer which does not point to anything, basically. So the problem is, it is undefined behavior. Oh, I'll go back to that later. It is undefined behavior to dereference an uninitialized pointer. By undefined behavior, I mean anything can happen with your code. It can crash because there's nothing behind this value, which would actually be okay, I suppose. I think it's bad if your application crashes, but it could be even worse. It could try to access some memory it's not supposed to access. It could print your passwords or whatever, you know? So that's definitely something you want to avoid. And well, since you cannot dereference a pointer, you might want to have a look at the API you are exposing, even on the Rust side, and make sure that all the pointers you are being given are valid. There's another thing I want to show you is that you cannot reassign a reference. So here you go. I'm going to go back to my foo, and then I'm going to create my reference bar. And now I'm gonna create a baz equals, I should have used 42 anyways. So I'm gonna say that bar equals baz. And so, oh, that's interesting. I thought I could not reassign it, but obviously I can. That's interesting. Anyways, no, that would be valid, but, oh, I see. I need, there you go. That's what I need. Oh, it actually works. That's interesting. So I can reassign it. I don't know if I can do some arithmetics with it, but that's something that I wanted to show you. Plus equals 1. Let's pretend. Does it work? Oh, this is bad. It seems to be working. So I can actually reassign the references, even though here that would probably be something I would not want anyways. So let's go back to what I wanted to show you about the pointers and the references. So here, I don't know if you remember APIs that we chose. The first one was toLower, which took a reference to a character, which I named str, which is basically, which is obviously not a good choice. And the toLowerCase, which is here, which actually takes a pointer to a string and the length of the string. So what I want to show you here is that we are going to write a test which is going to call toLowerCase with a null pointer, and we will see what happens. Okay, so let's do this. Test toLowerCase null pointer. Let's create a pointer. Okay, and I'm obviously not gonna assign it. I'm just gonna declare it. Let's put some random length here, 20, for example. And then I'm gonna call net toLowerCase and call it with the actual slice and the length I've defined above. And then I'm gonna assert that the actual slice is equal to the actual slice. I think calling this code would actually be okay. Let's figure it out. Yeah, it is actually okay, as you can see. What is not okay is dereferencing the pointer. So let's have a look at our function, the net toLowerCase here, which is creating the slice, and obviously something, it probably has no length or something, so that might be the reason why it's not being used. Let's try to have our code crash. So the debug is like the print statement, basically, for, it's a better print statement, let's say it that way. So here, I'm gonna debug the slice, which means I'm gonna have to somehow figure out what the value behind the pointers or behind the slice is. Let's see that. Okay, it's complaining because I'm using it after move, which is obvious. Let's go. So here, oh, that's interesting. So those are the debugs from the other test toLowerCase, null pointer. Oh, that's something very interesting. So here we have some, let's say, random values. There's even a negative value. So that's exactly telling us that there's probably something wrong. You see, there are zeros everywhere. There are some random value, a negative value, which is not supposed to happen. So basically, we are being given a pointer to some random address in memory with some random garbage code. As you can see, there's like 80, 58, 43, etc. I'm gonna do that again. And I have new numbers. So we are being given some totally random address, and we are trying to work on that, which is totally unsafe, and anything can happen, basically. I've been given two different pointers. Maybe I can reach a part of the memory I'm not supposed to. There are zeros everywhere, ones, and something pretty interesting in the end is the segmentation fault. So basically what happened is our program crashed at runtime. We do not want that to occur. So the question is, how can I handle the null pointer here? And there's a very simple way for us to handle that. And I'm going to show you that in the Rustlang primitive pointer reference, there are several ways to do it. The first thing would be to check if the pointer is null. So I'm probably gonna use this one because it's the easiest one. So basically what we want to do is check if the pointer is null. If it is null, we want to exit the function as soon as possible. There might be errors somewhere else in the code because the caller is going to call the function with a null pointer, but we do not want our code to trigger a crash. And there's another function which is pretty interesting here, which would be the asref here. The asref returns none if a pointer is null, or it returns a reference to the value wrapped in sum. What does it mean? It means that I might be able to write something like, I'm not going to do that, but I could have actually done something like if let sum my pointer equals stir pointer as ref, which is supposed to be unsafe, and then do something with my pointer. But that's not something I want to do. What I want to do here is return early. I just want to exit the function if the pointer is a null pointer. So what I want to do here is if stir pointer is, I think that was is null. I need to make sure it was return. Let's not do anything. I'm going to comment it because it seems a bit weird from the flow. Check for null pointer. And this is probably an unsafe function. Is it complaining? It's not complaining. Let me have a quick look. Oh, that's really great. As you can see here, the isNull function is not unsafe, whereas the asRef function is unsafe. So this is actually really good. I'm able to make this check without even having to use an unsafe block, which is great. So that's basically what I'm going to do here. I'm going to check if it's null. If it is, I'm going to return. So here we go. And the tests seem to be passing. I'm not really sure. There's a segmentation fault here because I suppose I'm not supposed to be doing that. Let's try to comment that out. No, there's still. Let's make clean and make test. I'm probably still doing something wrong. I suppose the pointer is not null because it was actually pointing to something. Let's try that. Debug stir pointer. So the pointer is actually not null, which is pretty funny. Oh, of course it's not null. I wanted to check the null pointer, so I should better declare a null pointer. So here you go. Good, that's much better. That's much better. To prove my point, I'm gonna comment out this part of the code and see how it goes. Segmentation fault. So you see, now I've been able to check for the null pointer. And so as you can see, there's another guarantee that should actually be taken care of, is that I'm not being given some random pointer and random length, but this is something I could hardly account for because in that case, I am not the caller. I cannot make sure that it's working. So I might want to comment about the invariance here. Make sure the str_ptr points to an actual string and len is valid before invoking the function. So yeah, that's not the best way to go about it, but yeah, I don't really know if I can do better. There's something else, maybe this here, the from raw parts could help us. There's debugger cert. There's something, no, yeah, that's very unsafe. So I'm not really sure I can find a better method to create my slice from that. So we're gonna just keep it that way for now. And in the next video, I'm gonna work on the next function. So we have done so far the to lowercase function, this function too, which actually takes a pointer. So it might be interesting for me to just change the definition And you know what? I'm going to do it just later, just after. And once we're done with two lowercase, two lower, so basically with these three definitions, we are going to start with some more interesting algorithm, which would be the find char inset, find char not inset, or find char not inset. And something is going to be pretty interesting with that. It's that we are going to be able to have a look at the algorithms being used, and we are going to be able to figure out what kind of data structure might be better. For example, here we can see that the set is an array. I think that's the best choice, but we are going to be able to reason about it and benchmark using an array versus using a set, for example, or another data structure. So keep it up. If you like that video, please add us a thumbs up, share it on social media. Don't hesitate, drop me a comment and let me know if there's something special you would like to maybe learn about in the next video. Thank you very much for watching, and I see you soon.